How to use the water mix calculator to estimate the resulting water parameters when mixing two different water sources. This tool helps growers predict important parameters such as pH, alkalinity, electrical conductivity, and the concentration of major ions like calcium, magnesium, and sodium. First, enter the parameters for the water source A. Start with the pH value, then input the reservoir volume in liters. Next, enter the electrical conductivity, or IC, which indicates the total amount of dissolved salts in the water. Then, specify the water alkalinity. You can enter alkalinity either as bicarbonate, HCO3, or as CaCO3, which is commonly used in water analysis reports. Alkalinity is an important parameter because it determines the water's buffering capacity. In other words, how strongly the water resists changes in pH. Next, enter the concentrations of the main ions, calcium, magnesium, and sodium. Now repeat the same steps for water source B. Once all values are entered, click Calculate. The calculator will estimate the resulting water composition after mixing the two sources, including total volume, pH, alkalinity, EC, and ion concentrations. A key feature of this calculator is that the pH result is not calculated as a simple average. Instead, the model takes alkalinity into account, since alkalinity directly influences how pH behaves when different waters are mixed. This allows the calculator to simulate buffering effects and provide results that are closer to what you would observe in real irrigation water mixing. EC and ion concentrations are calculated using mass balance, while pH estimation considers the interaction between hydrogen ions and alkalinity buffering. Because of this approach, the calculator provides a more realistic estimate of the final water chemistry, rather than just averaging the numbers. This can be especially useful when blending different water sources. For example, mixing reverse osmosis water with tap water to achieve more stable irrigation water before adding nutrients. With this tool, growers can quickly test different mixing scenarios and better predict the chemistry of their final irrigation solution.